Okay, now the voice is on. I got the warning that the battery is getting low, so that's why I'm connecting my headset. Hey, good afternoon. So any of you can some of you follow the lecture using the YouTube as well? Because the camera that I'm using is have this tendency to froze. So if it freezes, it would be nice to know that. Can some of you to take a look how I look in YouTube? Who would like to be a YouTube officer? You can put it in your CV. That look awesome. YouTube officer simulation of Mechatronic machine 2021. Okay, you can put it in your CV. Others, you can put it in your CV as well. So it's okay. So how many exams you have in the following weeks? How many? 100? 100. Okay. And you think that you will survive? No, yeah, no way to survive. Okay. What happens after that? You're gonna sleep like 2 weeks in a row, something like that. Okay. Hmm. I see. I see. Hey. So what are the other exams you are participating? What are the other courses you're doing this semester? Yeah. What are the other courses you do? What's the material selection criteria? Okay. One or two what? Ah. So it's already if you can memorize. Yeah. So if you memorize the course and name, then it's like half the material. Uh, yeah, because I think that the words that the people would like, they really love here is like digital, sustainable, modern. But you know what? We have American, well, guy in my team, and he always teaching us in this language matters, and he say that if you want to say nothing, use the words digital, sustainable, modern, because they information they carry is zero. Something. Tell me what is not digital at the moment. So means that the computer-based, everything is computer-based. What is not sustainable? Like you intentionally want to hurt the planet. I don't think you want to do that. No one is doing that. It have to be sustainable one way or another. So, oh, I need to be careful because this already goes out. So the recording is on. I mean, recording is not on. I'm not recording that to my computer, but it goes to YouTube. And is the camera still okay? You cannot tell. Okay. Also, our YouTube officer, can you take a look if there's any comments from online participants? There are comments already, but the problem is that it's such a small font that there is no chance me to see this. Absolutely no chance, because I'm old, and when you're getting old, my hands are not long enough. I cannot read this, cannot. So okay, so are we ready to get started? So this is it, meaning the last lecture. So the last lecture, what we're going to do today is that I'm going to spend a while to explaining you where are the practical applications where you can use this knowledge you learn from this course. It's a kind of unusual order in a sense that, remember, we started from the way that I give you why it makes sense to participate in a course. And I show you a couple animations about biomechanical things and this kind of thing. And then what followed was parcel this, parcel that, J-copy and this and that, virtual displacement and so on and so forth. And now we're kind of getting back to where we started. So I'm going again, what this means for us. And where are the applications where we can actually apply this knowledge in practical life and in engineering life more specifically. And that's what we're going to do today. And it's great to have this face-to-face discussion. For online participants, I can tell you that we have roughly 105 participants here in the lecture room. Is it this much? Bit more than 100. Let's say a bit more than 100 participants. So you're missing this. So I'm feeling bad that you are not able to join us here. So 100 participants here, and we're going to have a good discussion, I hope. Let's see. Let's see. By the way, do you know why I use this in-class quizzes? Because that's my way to communicate. Because never ever people are communicating with me in a lecture room. It seems that all the students hate me because when I'm asking something, everyone is always like, no words, no words. So it's always like that. So then I figure out the way that I can communicate is in-class quizzes. Today, not today, not today. And the reason being that because we are here in the lecture room, I mean, each of you guys are carrying a mobile phone, so you could answer questions using your mobile phone. But I was thinking that today is like relaxed meeting. So we take it easy today. So it's not going to be one of those uptight lectures where I'm asking, okay, what is a physical interpretation of Lagrange multipliers or anything like that. So it's more pleasant, I hope. Okay, so what's going to be the topic of today's lecture? So it's a real-time simulation and games. And like I explained you a week ago, so we are actually discussing more than just the real-time simulation. The real-time simulation and games is like a good example because that's something that each of you has already an idea. Games. You know what are the games? And each of you have their favorite games you like. We learned earlier that what are the games that you like? These are war games. You do Minecraft. Or is it for younger generation perhaps? I don't know. But anyways, the games is something that each of you have an idea what they represent. And now we're going to look how is that multibody system dynamics and the knowledge you learn can be used also in the gamification and game-based technologies. So we're going to learn a little bit about that and then some other industrial applications. But as usual, before jumping to that particular topic, let's summarize shortly what is that we discussed a week ago. So a week ago, we discussed shortly about how is it we can describe deformable bodies. And those are the bodies you can find in the real life. Remember in the very beginning, we said that we have this assumption of rigid bodies. This is an assumption that is a computationally okay assumption. You can assume many of the bodies to behave as a rigid bodies. But when you take a close look about each bodies in this planet, there is no such thing like rigid bodies. Everything is deformable. Question is like, is the deformation significant enough that it affects the dynamic performance? Sometimes it is, but most of the cases it's not. It's not. And the good example is that, certain component in engine, you can easily model those by using rigid bodies. They make no difference because the deformation is insignificant. But then on the other hand, there are components that are really making a significant difference. I mean, the deformation makes a significant difference. Cranes is a typical example. Belts is another example. If you model the belt as a rigid body, that makes no sense. Then the system cannot rotate. So it has to be a flexible body. So sometimes you need to model things as a flexible bodies to increase the accuracy. And sometimes you wanted to get the quantities That's like strain and stresses. You are getting interested, or you wanted to learn about what is a stress rate, what are the strain rates, and what is a stress history, which you need, for example, in a class called fatigue. What is the course name? Sustainable digital reliability. So that's what it is. Okay. So, but is there a fatigue course? What was that? Oh, right. So there's something related to fatigue. Okay, great. So what the information you need when you do the fatigue analysis is that you need to know the loading history, it's a stress history. Otherwise, it's not going to work out. So one of the ways you can use or you can compute the stress histories by using simulation, and you can model certain bodies to be deformable bodies. Not because of the deformation itself is significant, but you're interested in the stresses and strains. That's why. Biomechanical simulations is another example. The human skeleton is fairly rigid, and the deformation of skeleton is practically insignificant in terms of dynamic performance. But sometimes you want to measure the strains just because you wanted to learn what happens inside of the human body. And that's something that you can then model bones to be deformable bodies. Really? How come? So it's still the first slide. How that is even possible then? Hmm. Okay, so what should I do then? Oh yeah, I see, it's like this. Why did this doing? Should I use this kind of presentation mode? Would this be better? What appears now? It changed. Okay, hold on. Oh, there. Oh, now I got the commercial in my YouTube. Huh. No, this is something else. But one thing that I don't know, another day I was checking. Oh, this is not even my lecture. This is something else. Okay, but YouTube officer, you will make sure that everything goes smoothly. What was that? Me? Of course, of course. Haven't you seen my car? Yeah, that tells you everything. How much money I make from the YouTube. So you should see it. You should see it. Okay. Uh, what is that I was explaining? I got confused. What was the thing that this fatigue thing. Name of the class is digital sustainable. that thing too. Okay. Yeah, I see that today's lecture is going to be very lengthy because of this communication. You guys, don't you know the rules of LUT? No communication. No communication in lecture room. I thought that that's the rule, that it's written in front entrance. Come on in. You can come in, but don't communicate. But that's not the case. Okay, so now back to the real deal because we have so many things we need to cover today. So I said that the deformation can be modeled by using this landmass approach, which is like very coarse, very rough way to do it. It been used in a history, but not so much anymore. Certain applications like wire ropes, cables, are still modeled by using these landmass approaches, but other than that, it's not heavily used anymore. So the method that is heavily used is a formulation called floating frame reference formulation. This is what I'm going to teach you in the next class, which is a simulation laboratory course. I don't know if I mentioned this to you earlier, but if you make a list of best courses in LUT, first comes simulation laboratory course, then comes nothing, then slowly other courses. So it's by far the best course in this university. Guess who is a teacher? No need to guess that. Okay. Uh, yeah, the floating frame reference formulation. This is a fairly complicated, and if you can, after my course, if you learn where the name floating frame is coming from, I will be very happy to that, because it's a fairly complicated procedure. But basically what the idea behind is to combine finite element model and multi-body system dynamics. Problem is that typical finite element model, by the way, are you guys aware of the finite element modeling? Have you heard that? So it's like the method you can use that to estimate the structural strength by using elements, which look like, in most of the cases, the model look like structure that is there is a fishing net top of the structure. That's how it looks. And you can compute this element behavior. And once you're adding up the elements, then you can get the behavior of the entire structure. Now, the problem in the finite element method is that it easily gives you the model with a very high number of degrees of freedom. Typical finite element model is roughly 100,000 degrees of freedom. It could be 1 million degrees of freedom, 10 million degrees of freedom. That's possible too. That versus the multibody, where we're using 6 coordinates to describe the rigid body motion. They don't match. Think about 100,000 versus 6. The scale difference is so huge that you need to do something to your finite element model. And what you do for your finite element model is a technique called Modal Reduction. So it's doing exactly what the title says, is reducing the model size using kind of advanced method such that you don't really lose much of a computational accuracy. The accuracy is still okay, but the dimensions are way lower than originally. So it's based on the idea to compute eigenvalues and eigenvectors of your structure. Eigenvalues and eigenvectors. And those are the ones you're then using in your computing. And this is how they look. This is a simple grain structure. And eigenvalues and eigenvectors look like this. If you take a look at what's mentioned there, there's like a number that in parentheses. That's the frequency. 110 hertz, roughly. This is 51 hertz? Yeah, 51 hertz. This is 148 hertz. These are the low frequency vibration. But then there's going to be higher frequency vibrations. Most of the cases, these high frequency vibrations is insignificant in terms of dynamic performance. You can ignore it. And when you ignore it, you can improve the computational efficiency. That's in a nutshell. That's what's going to happen in a floating frame reference formulation. Here's a natural frequency that is pretty high frequency. The frequency is 12,000 hertz. Deformation looks like this. How important is this deformation in terms of grain? Not important at all. So you can easily ignore it. This is how it behaves. And that's the kind of the idea behind. High frequency vibration, ignore it. And you don't lose much if you know what you're doing. So with that, okay, now back to this real-time simulation and games. And let me go back to the background. I started on Tuesday about explaining a little bit about how there's this big trend that the material flow processing is, the business related to material flow processes is getting smaller. At least the competition is getting higher. The business related to data acknowledgement is getting bigger and bigger share of the business. And the bigger part of the business is this, what we can actually offer, this simulation technology. How is it we can offer some extra top of the actual material or the physical products? That's what we can offer for customers. How exactly? That I'm going to explain to you today. So I'm going to continue a little bit about the background, and then the main body of my presentation today is these product processes examples. And then one thing that you need to remind me, then there's this summary as well. So what are the materials that I'm expecting you to know in the next midterm exam? That's going to be the last stuff that I would like to explain to you. And that's it. So we're this close to end. So a few more observations about the background, and let's see if we can play this video. This is a university maintenance draws made by using a photogrammetry. Is it going out from the YouTube? Okay. Oh, this is full. Audio doesn't work. Oh, okay, all right. So then we cannot just look at the videos. It's very low voice here too, so it's practically impossible to hear that. So these are just a few models that we've been building. But look at the picture in the beginning was a university maintenance trust. So it's possible to create. This is a real picture from that. But you can also use this kind of laser scanning and photogrammetry to create a virtual environment pretty much from any physical place you want. And there where you can put your machine to operate. And sometimes it comes with a certain advantages because sometimes this virtual world, something that is fully like virtual, there is no connection to reality, has certain drawbacks. And the drawbacks is that maybe the dimensions are not exactly what you can find in a real life. So when you're using this photogrammetry, you can take this place, scan it, and you can make a digital representation of this place. Comes with a certain advantages. Like then you really know that okay, how well your machine is capable to operate with a certain dimension. Is it colliding with the object and so on and so forth. All right, so this is where we started in the class, this class too. Remember, this was something that it's important for us to understand, like kind of like a representation, how are the machines in real life. And we learned in the very beginning that the machines are not just a mechanical component. They are mechanical component combined with an actuators. And the actuators, they can be hydraulic actuators, pneumatic actuators, electric drives, water hydraulics, well, whatever you want. The important thing is that those things are combined together. So then when they are combined, then you have an asset, you have kind of like a tool that you can use to analyze the dynamics. Otherwise, it's not going to be possible to do so. Control system. You know that too makes a huge difference in terms of dynamic performance that need to be combined to your model as well. User, that can be combined by using these real-time simulation. Otherwise, impossible. This, by the way, this picture is something that gives us a possibility to have a better understanding about the user. And that's exactly what we're going to do next, because we're going to use this concept in a way that we are allowing the customers and users to play the game. And while they are playing the game, we learn what are their desires, how they want to tune the parameters of the model, and then we can also give them ideas. Would you like to purchase the product like this? Try this. Try how it feels like. Try how is efficiency of this particular machine. Try how is the productivity, energy consumption, and so on and so forth. All that is possible with this physics-based real-time simulation. So what's the behind? What's the technology behind? Correct. Multibody system dynamics. So that's what you have learned from this class. Although that it might sound like, okay, oh my God, we were studying this pendulum. Remember this pendulum. Some of you were crying when we solved the equation of motion, but seriously, it was kind of silly in a sense that it was simple mechanism. But the beauty of the approach we learned is that you can scale it anywhere you want. So you're not limited to this simple pendulum. And if you wanted to combine this to hydraulics, not a problem. You have the skills to make it happen. So it works with no problem at all. Okay, the working process that is also mentioned here, this is typically very important to take into account because if you think about that you have an excavator in one of those rigid surfaces, it makes no sense. The excavator will be okay. There will be no problem at all. But if you put your excavator in a environment that there's a deformable ground, then you actually can start learning how exactly your product is behaving. So you need to have each of these boxes addressed. Otherwise, it's going to be artificial. It's still going to be artificial, virtual, but if you don't have all the boxes covered, then the solution is not going to be very good. So this is how they look. So these are the examples about the real-time simulation. So you see that this is an excavator model within a deformable ground. and it's operating with the hydraulics exactly the way you have learned it. The multi-body mechanism is modeled exactly you have learned it. Not exactly, because the one thing that I have not mentioned to you is that there are many different varieties of how you can put together equation of motion. We have learned two ways to do it. The one that is based on these Lagrange multipliers, another one that is based on this coordinate partitioning. But then in addition to that, there are, say, several other ways to do it. And some of them are computationally efficient in a certain applications, while in a certain applications, other is more efficient than others. So it's almost impossible to know which one is the most efficient in your particular case. So that's why we have all these currently typically used formulations implemented. So we're simply testing. We're trying, is this efficient? Is this more efficient than others? And this is the way we find the most efficient approach. So this is how they look. And this is a environment which is a real environment too. This is a photogrammetry-based environment from industrial area that is located somewhere in the north. Don't know exactly where. But it looks fairly realistic, even with those, many of the details are included. And then you can put your excavator to do something in that environment. And then it is pretty much everything we needed. If there is an excavator in the real time, there's a user, there's a control scheme, there's a hydraulics, there is a mechanics, there is a environment. All these 5 boxes are checked. So then we have all the ingredients needed. Where is an excavator? There. What is this MEVEA? You guys know what that is. That's a university spin-off located in that business park, that direction. So what I would say, 200 meters that direction. That's where the MEVA is located at. And they are specialized to real-time simulation. And of course, they are using multi-body system dynamics in their products. Okay, now the product processes examples. So here are the different product processes that I would like to explain to you. And I'm going to cover some of them with you. So, of course, simulation can be used in a product development. What's going on? Picture doesn't fit. Okay. How come it's changing? How come it can change? How much it is off? Okay, so let me change that then. But this is something that a big puzzle to me. So why did he doing that every now and then? That I don't get it. Ah. So window this one here. No, like this. Let me go back. So we were here. This one. The previous. I look at this one. How is it? But I think it's going to take another 20 seconds or so. That's perfect, isn't it? It's a little bit off. It's good enough. Okay, good enough. Okay, so here are the product processes that I'm about to explain to you, and where the simulation, kind of the simulation we learn, can be used. You know that there are other simulation techniques like this finite element method that we briefly discussed, and then fluid dynamics and many, many others. But today we're going to focus on these computational dynamics. So aspects that are capable to describe dynamics of the system. And then we're going to look how is that they can be used in a product development, in marketing, in service business, new business opportunities, and others. So others I'm not going to cover, but I'm going to take a look at the product development, and then we're going to look at the marketing thing, and then the service business, which I think is quite interesting, that the most exciting for clearly is going to be these new business opportunities and enhanced automation based on simulation. That's going to be the one that I like the most. Later we can give a voting which one you like the most. Okay, so let's get started from gamification. So in the product development, It's mentioned that it can be used in a kind of in a concept where we learn the customer feedback as early as possible in the product development. This is extremely important because the purpose of the product development. This is my statement, but I really like my statement here. So in my mind, the purpose of the product development is to serve the customers as well as you can. Because what would be another reason to have a product development? It's hard me to imagine any other ways. Some people are saying, okay, because they need to create the new technology, new solutions. But for what? Whom? Who is going to benefit for that? For customers. So otherwise, you're completely lost if you think, oh, I'm going to do this because it's so cool and I like it so much. Nice. But what about your customers? Are they liking that as well? And that's a really important question in the product development. How well are you really serving your customers? And that's something where this game-based technology comes into play. And you can ask your customer to test and tell your feelings. You like it or you hate it. Sometimes, at least because we're in Finland, people always say that it's okay. When they hate it, they say it's okay. And when they love it, they say it's okay. So it's really, really hard to make an interpretation like you really hate it or what is you feeling about? This is when you can use some other techniques. So there are possibilities to measure the stress level of operators. And if the stress level is very high, you can kind of think of, this guy is actually, even though that he say, it's okay, he or she really hates this product big time. Or you can also say when you see that the stress level is moderate, so maybe there's a chance that this is a winning product. There are tricks to do that. And you can also see like how often you need to focus on your eyes in the different details. That also tells you a little bit about how is the usability of your products. So this kind of gamification concept can be combined with this technology that they're measuring the biomechanical signals, which is very delicate business. Okay, so I'm going to explain that to you. The things that are not mentioned here in details are, the IoT or embedded model. So that's kind of obvious. So we can make a simulation model. We can embed that as a part of the product, like I will explain to you in one of the examples. And that can give you another features of the user, such that the user can enjoy the use of the machine more than without that option. Then the hardware software testing, that's of course is very important. So I mentioned earlier that this material flow processing is changing to be business based on the data acknowledgement. And you can easily see that in companies that are making like heavy industrial applications. Those companies used to be fully occupied by engineers from mechanical engineering. 100%, no one else. Right now, there's all people from different kind of discipline, and they're all working together. There's a good amount of people that are specialized to computer solutions, to IT solutions, and that tells again, that there's a lot of software. Software is very problematic because it needs to be tested, similar way that the structures need to be tested. How are you going to do the testing? Well, you can take your product out there and try how well it works. And if it's not working, you take it back to factory and fix it. And you keep on doing this, sending the machine back and forth. It's going to take forever, and the quality is not going to be very great. So, not recommended to do so. So, you can use simulation to test your software, and this is what companies are using at the moment. So, there could be real-time simulation model, which is then tested to see how well your software operates, and then the user is then testing, doing all kind of stupid thing to see whether or not there's any serious difficulties. Okay, but now first is gamification. All right, so this is like my observation. I don't know, this is not the fact, but my observation about the business. This is saying that the product lifecycle management, let's say the product selling aspect, doesn't change. What the heck? Oh yeah, because I know why. Because I'm not using this presentation mode. Thanks that I have, without the YouTube officer, I would be forced to deliver this lecture twice. How is it now? You can see it. changed. Okay, so I was saying that business is moving away from emphasizing the technical aspects and started to emphasize the user experience. I can give you a couple examples. And the mobile phone is a good example in my mind. When you purchasing the mobile phone, there is a website you can learn all the technical details. What kind of battery technology they are using, what kind of this and that they're using. No one cares. No one cares because you do the purchasing decision based on the expected user experience. You think, okay, this is going to be awesome phone because there are these features, user experience features that makes me happy. That's your purchasing decision. Another example is a passenger cars. Of course, the passenger cars comes with a lot of technical details and technical specs. But then when you read in the magazines that are evaluating, how good are the passenger cars, they're usually using the statements like, this car feels good. Feels good. What the heck? Feels good. Like, okay, what that means in technical terms? It means nothing. It's a user feeling, user experience that is higher than in other products. That's bad news for us, mechanical engineers, because feelings and mechanical engineers, no way. They don't get along. They don't fit the same room. Let's put it this way. So so it's very, very hard to have an understanding about the human feelings, humans in general. And that's what makes things difficult because the humans are the ones that are making these purchasing decisions. How can we solve this? Well, here comes the multibody system dynamics, and we can build these games, and we can ask from customers, you like it or you hate it? And then they say, yeah, it's okay. But then comes this biomechanical or the biosignal measurements, and then we can detect, this student hates this lecture. I don't want to use it here in the lecture because it will be all red all the time. So no here, but customer feedback, there we can use it. We can use it there. Okay, so the idea is this, the corner or the kind of the picture that is upper left corner shows how is the digital tools are currently used, not seen. So which one? So which one is now not crude? So left side or right side? But it was the same thing previous time, right? Oh, that's okay. That's just a minor thing. So hey, I have a message to online participants. Come in the lecture room. There is still let me 1, 2, 3 empty spaces here. So come here. There you can squeeze in. Is it even more? Yeah, there's even more. Yeah, there's more there. Yeah, I can see that in the back. Okay. Okay, let me read what is in here in left. So the box in most left is a digital tools, which are this computational dynamics, fluid dynamics, heat analysis, name it. All these kind of tools that you can use to have a better understanding about the physics. Now, usually those tools are used by product development team. And now how the product development project gets started is that you first have a questionnaires asking from your customer that, okay, what do you like? So what are the things you like? And based on these questionnaires, you try to build a picture in your head, like what are exactly the product that the customer likes? And then you put the product development team to execute that. And they're using these digital tools to speed up the product development process. But how well are you really addressing the needs of the customer, depending on your initial guess. And in the worst possible scenario, these digital tools are just speeding up to make wrong decisions. So they are not guarantee you to make the right kind of decisions. And that's what matters. That's really what matters. Are you really serving your customers or are you not? Now we can change the game. And we can change the game in a way that we can use these digital tools to have a better understanding about the customer needs. And this is what they're doing in the Finnish companies already. There's a company that is making mining devices, which you may think that, okay, the user experience means nothing, absolutely nothing, because it's they're used in a mining, and the mining is nasty place anyways, so you cannot make their life to be any better. But still, it makes a big difference. So in a Sunweek, once they have a new product, they will ask customer to come over and try that by using real-time simulation and tell me, would you like to purchase this kind of product or would you not like to purchase this? And if the customer says, yes, I'm interested, then the product continues. And if the customer say, no, I don't like this. I don't like it because of, this and this is not what I would like to see. That's where the project ends. So it's a very important decision because worst possible scenario would be not to stop the project, but continue until the product is ready. And then the customer comes over and say, oh my God, this is not good at all. I hate this big time. I'm not going to purchase this. So what are you going to do then? Then you're losing a lot of money and a lot of time. Time is equal to the money. So that's where you can come and use this gamification concept. Now, today was a open lab day. The laboratories were open. Did you guys recognize that? So did you test it? Did you went to laboratories? You did. So did you saw that there was a simulator about the excavator available too? And there was a game related to that excavator. Did you guys try it that? So you guys try it. You did not. Okay. So there was an open laboratory day today, and there was an opportunity to run a game which was honestly a bit boring because it was an excavator. No explosion, no shooting, so nothing like that. But just moving dirt from the ground to industrial hopper. But there were opportunities to tune the model. So you can modify the model. And based on the way that the model was modified, we can learn, okay, this is what the customer wants. So if this is what they want, we can build the product exactly fulfilling their needs. Is it still okay? Okay, so and this is where the gamification comes into play. And here, this is where it can be used. This is no longer in operation because one of these simulators was moved to this laboratory you visited today. But this is how the Sim Studio used to look like. There were 2 platforms for real-time simulation, and they used to be open 24/7. Do you recognize this guy? Suraj have no idea how to use this excavator. Absolutely no idea. If he would be an operator, this company would go to bankruptcy like within a day. No chance. Take a look at how long time it takes to move one pocket from ground to this truck. Unbelievable. So now it is like 2 hours past, and he's still struggling to do it. So not looking very good. Suraj is not online. Great. Okay. Look at this. So this is unbelievably slow. So why is that he using tracks? Oh my God. Even the view is incorrect. So this video takes a long time. Finally, he's approaching. He is approaching. Okay. This was an environment to test this, and then there was another guy. I don't know if you recognize another guy, Tuhin. Is Tuhin teaching you anything here? No. Okay. All right, so let's move on. User training is the next topic. Here's a brief story about the user training. Here's a real-time simulator that was used to train this crane collar. The operators of that crane to move the containers from the harbor to ship and from ship to harbor. And this is a good example which really makes sense to use user training based on the simulation because these kind of devices are expensive. And making the ship to just the weight that somebody's training to learning to use a crane, that's going to be too expensive to do so. And there could be another problem that a beginner can introduce some damages to crane, which is also very expensive. Now, why is that I'm showing you this simulator here? Well, the reason is that this simulator is actually not very new. This was built already 15 years ago. Well, I was about to ask, remember those times, but no need to ask that because you guys don't remember those times. But I can tell you from my experience that computers back then were not that advanced, and the computational power available at the time was not too advanced. And still, this was a simulation model that was capable to run things in real time. Of course, you can see that the VIROPS models were not too realistic. You don't see any string effect in the VIROPS. The VIROPS, the visual appearance is not too realistic, but still 15 years ago, we were able to run this in real time. And of course, it's not looking, up. Look at the environment. It's not so great, but still, computational power was already there. Today, what we can do in the real time is way more complicated than this. Way more complicated than this. This was, by the way, one of the environment that was used to train these operators. So it was based on hydraulic cylinders, which is typically not used anymore. The reason is that hydraulics can produce so much power that you can make your life dangerous. Let's put it this way. This is another kind of crane which is moving these boxes from hopper to crown. But let's move on because these are the kind of like how it was back then. Now, fault diagnosis, embedded models for maintenance, and digital twin service. This is something that is quite interesting too. Here's an example about how is it we can introduce different faults and we can build a library about different symptoms. So we can run the simulation model and we can introduce some artificial faults in the model and then we can see what are the consequences. Why? Because then we can have a full library about different symptoms, and once we get the signal from their field, then we'll learn exactly, okay, they have to be this component broken because the behavior resembles that kind of behavior. So you can build these symptoms. This is a kind of silly example where I'm going to be broking the hoses. And usually if there is a hose broken, it's not going to be as serious that is showing here because there's going to be a number of hoses broken and that's not going to be very common. So the hoses are disconnected. And this is kind of obvious. So if you see that the hose is broken, you can even see that visually. So, but this is kind of idea how you can build this library. More hoses. So it's back in operation. Hoses are broken. Now it's completely dead. So if it is like this much, I don't think you need the simulator to figure out what's wrong in your machine. Okay, but then something more exciting than that. The real challenge in a simulation is that it's practically impossible to build one-to-one model with the reality. That's not going to happen. And weather forecast is a good example. In the weather forecast, they're using these supercomputers to try to make the, the prediction to be as accurate as possible. And they can make a good prediction for next day, for 2 days in ahead, 3 days in ahead, week ahead, not so much, 2 weeks in ahead, not at all. And that's simply because there is always some differences between the real world and the simulation model. And they can get along well, but then they separate it. Once they separate it, they never come back together. That same holds for mechanical engineering. It's practically impossible to build a model that every single details are modeled in a way that there is no difference between the reality and the simulation model. What happens as a consequence? That things getting started well, and then they separate it. First a little bit, then a little bit more, and eventually these two things has nothing to do with each other. So what we need to do is that we have to have a mechanism that we are merging the simulation model and the real products together. And we can do that because we can use technology based on Kalman filters, space observers, state space observers, to force them to move together. Basically, the idea is that measurements used in real machines are used as an input to simulation model. And because they are used as an input, that the simulation model always follows the reality. And if it always follows the reality, what's the benefit of that? Well, then we know the full state of the machine every given time. What is the benefit of that? Well, we can make a tailored maintenance, which is still not the great advance. But we can also tailor the product to be better serving the customers. We can use a software-based tailoring to make sure that there's a product that is tailor-made for your needs. And that's where this technology becomes to be super handy. Here is an example. The crane in the left. How are the online participants? Can they see this? Kind of. Okay, so the one in the left is representing the reality. So this is where the measurements is coming from. The one in the middle is the one that is replicating the reality, and then the one in right is just a simulation model without this feedback, without this connection. You see that already this time when there's a couple seconds advance, there's a difference between the simulation model and the reality. The one in the middle is still with the reality. And this is something that we are trusting a lot because it can be used to estimate forces in your system. It can be estimate the payload of your structure and so on and so forth. The options are almost unlimited. That's how I feel. And now comes the best example. So this is by far the best example, which is related to. So it's back. Is it back? Have to be somehow related to Wi-Fi of this place. But I'm back. Okay. So this first example is about faster than real-time simulation. So now I'm going to stretch your brains a little bit. In a real-time simulation, what we do is that we can compute all the necessary computing, and then we're waiting to real-time to hit to us. And when the real-time hit to us, then we proceed in our computing. And then we're going to do all the operations again, and then we stop to wait to real-time to hit to us. And then we're going to advance again. So what's going to happen if we are not going to waiting the real-time to hit to us? So we're going to move like time-wise here. The real-time comes and follows us, but we're going to still go further ahead of the time. So what's going to happen to us? It gives the opportunity to see what happens in the future, right? Because we go faster than real time. So here, that if I'm going to select this one, this is what's going to happen. If I'm going to select this one, this is what's going to happen to me. So now I know all the possible choices. So then I can use a artificial intelligence-based algorithm to select the most desired consequence. And then I do this action, and then I again projecting my motion scenarios to future. And again, I see what's going to happen in the future. I'm selecting the most desired one, and this is how I proceed. And this is ability to see what happens in the future. That's pretty amazing. What do you think? That's a technology that is not yet here, but soon will be. But let me show you an example about that. And then there's another example where we are teaching the reinforcement learning algorithm to operate an excavator. So there's no human operating the crane, but it's fully based on our reinforcement learning algorithm. So those are the two examples. Now this first one, this is coming from Aalto University. This Professor Perttu Hämäläinen is working in Aalto University. This game here that I'm operating here, this look like Angry Birds, exactly like Angry Birds. The purpose of this is to hit these balls. What's going to happen if you see all the consequences? If you see what's going to happen because of your action, this is how the Angry Birds will look like then. You see all the actions here. You see what's going to happen in the future. Not fun to play this game because it's too simple to play this game. Idea was to hit these green boxes without moving the others. It's simple because you see what's going to happen. You see already. Okay. I'm going to show you another example. This is just a little bit of mathematics, which forget about that. So soon there will be another material that which is very exciting. Okay, so let's take a look at this. This is the puzzle solved. Okay, now there's a car that is driving to cross a road, and there is a kind of heavy traffic, and you're using conventional control algorithm. Not good. Next one, you're predicting what are the different motion possibilities to future, and then you're selecting the most desired one. And you can make it happen. This is pretty amazing. Now what is needed is a more computational power, and then you can make it happen. This is an excavator that I mentioned. So this is fully operated by reinforcement learning algorithm. So there's no human at all here. So we just simply mentioned the algorithm that, okay, go ahead and move the dirt from the ground to industrial hopper, and let us know when you're ready. And then it's learning this system, is operating these sticks, and doing all kind of stupid thing, a lot of stupid thing, more stupid thing, and eventually it recognize, oh yeah, this is how it works. So this is how I can put my shovel in the ground, and this is how I can get the dirt from the ground. This is how I can put them in an industrial hopper. Learning is a painfully slow. And after painfully slow learning, take a look how is the best outcome. This is the best operation scenario so far. Remember when I was criticizing Surats? Artificial intelligence is even worse than a Surats. So it cannot even do the same. So nowhere near. Look at how slow. Like, oh, why you need to be this slow? Just full speed ahead. But no, it's slow. And this was based on a lot of training. The first training was not successful because usually it's started in a way that artificial intelligence is doing everything except the work you're expecting it to do. But everything else, moving, putting the excavator upside down and, all kind of stupid things, going down in this hill and so on and so forth. All these kind of things. What's the time? 5:10. So soon we need to move on. Safety studies. Okay, so in the safety studies, we need to have a human representation. And here's a human representation. Yeah, this is it. This is it. The same story. So this is a human representation, which is not this time used in safety studies, but it could be used here. This is used to measure the productivity of human. So this is, you guys all in that class. What was the name of that class? Oh my God. No, don't tell me that it was digitalized, sustainable. Okay, great. Happy to hear that. Okay, so, but anyways, in that class, I explained that this is used in to measure the productivity of human, and it's actually used for that purposes because this is a sponsor. This is a huge big project that is sponsored by Daimler, Mercedes-Benz. They product that they do the Mercedes-Benz. Have you ever heard it? By the way, no, it should use two hands. It's using two hands when it's walking. Okay, back to me. So remember the money that I made from the YouTube. So guess if my car is a Mercedes-Benz? Yes or no? No. Well, my car and Mercedes-Benz couldn't be more far from each other. I can tell you that. My car is this end, and the Mercedes-Benz is another end. This guy, no, this is not Surat. This is not Surat, but this is again this project is sponsored by these big car manufacturers, Daimler, Volvo Trucks. What else? Scania. Scania was there as well, but that's about it. Why they would like to do this? Why is that they would like to have this human representation? Well, first of all, let me tell you the feature of this human representation. This human representation is controlled by roughly same kind of algorithm that excavator. So it's The motion is based on something that is called motion mockup units, which is make it easy to control it. You basically say to this guy that, okay, go ahead and walk close to this table. Take a hold of the screwdriver and come back. This is kind of the task you're giving to this human representation. And they do this because when they're building a new production line, everything can be predicted. How well these robotics can do they work, how fast they can weld the components together, how is it they can do the assembly work. But then comes the big question mark: human. How many human are you supposed to have in a cell? Can they do the operation in a given time, or do they need more time? This is a big question mark, and usually needs quite a bit of trial and error to figure it out. How is it the human are behaving? So that's what they wanted to get rid of. Not humans, but this uncertainty related to human behavior. So then they're making the simulation model, then they're testing how long it takes. And they can also use in ergonomics, because certain operation you do in assembly, you need to keep your hands kind of like uncomfortable situations. So they can measure, is it how long you need to do it? And is it too heavy, physically too heavy to do the assembly work? And that's great, because then later if you go to see the doctor plays this video to you and say, you're okay. I can see that. So go back to your work. No, that's my comment. So that's not the purpose of the project. Okay. So more operators. So they are putting together an entire car, I think. I don't know what these guys are doing. They're kind of, I don't know what is that they're doing. No, because we never scored 100%. No, we did not. We did not. I made a awful lot of, no, I made an awful lot of preparation. I was practicing or dancing a lot. But because we never scored 100%, no need to do it. So that's what happened. No, 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 it wasn't me. It wasn't me. My hand was all the time visible like this. It wasn't me. Surats, don't know about him. Really don't know about him. But it cannot be me, because you can only log into system with your student ID number, and others cannot do it. So it have to be some of you guys. One of you guys is guilty. Who? I don't tell. No, I don't tell. I don't tell that. Okay, so here it is. Conclusions. So this is the thing that I would like you to be kind of memorize. That there's this mechanical things, actuators, control system, user, working process. You put everything together and then it makes sense. And you're missing one of these boxes, kind of not making much of a sense. Okay, these are the courses. Here comes L. This is kind of the video that I like. U, what comes next? L? No L. T. This would be an in-class quiz, like L, U, what comes next? And I'm sure we do not score 100%. I can guarantee you that. Now here's a rector of our university, seriously lost, and that's why he's angry. They left him in that island. What was that? I know there is an island, small island, and he spent his summer vacation in that island, and that's why he's that pissed. Looking the others like, if you're not coming right now, I'm gonna fire you all. That's his face. Okay, now let me change my presentation to be this one. Uh, Hold on, I need to do this. Uh, okay, here it is. How it appears now? Is it okay? Oh, no, 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 not this, not this. Uh, Last one. What that one? Okay. Yeah, I understand. I understand. I need to change this one. This one. How is it now? Yeah, it's there's this. How can I get rid of the delay? Is there a way to do it in OBS? No way to get rid of that. But I was struggling today to get rid of the background. I installed all kind of packages to get rid of the background, but look how it turned out. No success there. And I thought that it's going to be too heavy thing to carry all my green screen here, so that's why there's this background. Sorry about that. Only lecture with background. Others were with this chroma key. Yeah. Okay, so this one. Can I keep it in this presentation mode? This mode. Is it okay? Okay. So here are the material that you need to. How it is like a little bit blurred in the middle, isn't it? Okay. So is it getting better if you? No, it's all the time blurred a little bit. Okay. Yeah, I see that. I see that. It's okay other places except here in the middle. But that doesn't bother you. You're not developing a headache because. Are you developing a headache because of this? Yeah. Okay. No, yes, I'm sorry, but no one else is seeing any problem here. So it's maybe it's just you. Yeah. So it's kind of weird. Okay. These are the subject matters that I'm expecting you to know when you get into next uh, midterm exam. And let's take a look at it. Let's memorize something which is extremely important. This is what we agreed. Remember, we had an agreement. And this is agreement that this is the way. Oh my God, it is actually a little bit annoying that when there's a text. Yeah, that's what I was saying. So I'm gonna take a look at this, and you guys can take a look at that. So we made the agreement that there is two mandatory items to pass the course: written exam and simulation work. How is that you doing with the simulation work? Others? Others, because there are thumb up. All of you are, except the front row is it okay? Good, good, good. Hopefully you can do fine because remember this is something that we are expecting you to do. So you cannot come back later and say, well, I decided not to do it. So that's not the decision you can make because this was an agreement we made in the very beginning. Other items you can choose however you want. The written exam is a mandatory thing and you need to do both written exams. Or you can go with the conventional paper exam. Not recommended. Because I'm going to intentionally make it so difficult, this paper exam, that I couldn't pass by myself. Seriously going to make it so difficult. Because I would like you not to go there. Because then I need to read your handwriting and I need like, oh my God, what this guy is trying to say here. And then I got like really fed up and thinking like, have to be worth of zero. And then I give you zero, and then you come back to my office and you're yelling to me that, oh, you did not check it correctly and all this kind of stuff. Now, this automated grading is so beautiful. No yelling, no place to complain. So it's so beautiful. Yeah, so written exam is a mandatory thing. But if you want, you can do this paper exam. But avoid it as much as you can. Avoid it as much as you can because seriously, it's a little bit painful. But I mean that if you decided to do so, it's okay to come to my office and complain. It's okay because you know certain the second class it used to be just the paper exams. And I encourage the students to come to see me and complain and argue about, how they should get more points. And it's always a lot of fun for me. And I promise that because sometimes you take your relatives with you, and the relatives helping you to build a stronger case. Even better, even more fun. You take your mom with you, it's going to be great. But no need to do it. No need to do it. But consider that as one option. Written exam. Okay, so now I make a changes here. So the written exam, we agreed that it's going to be in week 43 and week 51. So I'm going to put it open next week. I mean, uh, this week, Sunday night, it will be on. 005. It will be on at that time. You will have 2 weeks time to answer or put your answers. 2 weeks. So it's not going to be a week time, but 2 weeks time. You will have 2 attempts, business as usual, but a longer period of time because I know that you guys are busy and I want to be flexible because it doesn't make much of a difference if it is week or 2 weeks for us. But for you, I think that it makes a big difference. So 2 weeks, 2 weeks. Again, highly recommended that you do your first attempt in your earliest convenience. It will be Monday, 6th of December, which is an Independence Day. Official holidays at the university will be closed on Monday, next week Monday. Yeah, that's right. But Tuesday, and if you want to take it Monday off, fine, but do it on Tuesday. So then you can see how well you're doing because this exam is different than others. Because this is more like oral questions. How you like about the class and what's your favorite color? This kind of questions. Could be a bit more complicated than that, but that's where you need to kind of familiarize yourself the level of difficulty. Then you have one more attempt left. So don't waste your first effort. Read before you do it, but still highly recommended to do it as early as you can. Okay. Then if you want to torture yourself and me, then the way to go is to go these final examinations. So those are the real physical exams that you're getting physically here in university. You will get the exam paper. You need to put it in a handwriting. And that's it. That's possible. Not recommended. Not recommended, but possible. Okay, so the rules are clear. They're clear for you. Okay, not clear. Okay. And when was the deadline for this simulation assignment? Was it the 19th? That's a deadline. But you guys, are you aware of the fact that you can submit it that earlier than that? No penalized. Well, no, I mean that you can do it today if you want. So there will be no penalties if you do that. But if you're late, then there will be some penalties. Okay, here's something that if you are struggling big time with your simulation assignment or other things, let us know in advance, not later, because once you come back to us and say later that, well, I was busy and, my mom's dog was not doing well and all this kind of explanation, then we don't want to hear those stories. We simply don't want to hear them. But if you come in advance, then I'm thinking that my mom's dog will not do well and because of this stuff, then it's okay. Then it's okay. Then we can be flexible. All right? And honestly, we are not even that much interested about your reasons. So if you need more time, we can make it happen for you. But there's a limit. There's a limit because student union will go after us if we're going to give you too much time. And the problem is that we're supposed to finalize the grading within the certain time limit. And if we're unable to do it, they're going to put us in a blacklist. So we would like to be flexible, but the student union is not allowing to do so. So I'm so sorry. I feel bad about that, but but what are you going to do? What are you going to do? We have to obey the student union. So that's the way to go. No, no, no. I'm crying. I'm crying on your behalf. On your behalf. Yeah. Well, no enrollment if you're going to select this online exam. No enrollment. Same thing that you did in the first case. So, but if you decided to do this second option, these paper exams, then they're all going. Yeah. So if you did the first one, you are already in a second one. And even those ones that I did not make the first one, they can do the second one, but that makes no sense because you're already kind of out. And the next year will be the next opportunity. I mean, that there is always this final exam opportunity, not recommended. Okay, so what the things that you need to know. Embedded technique. So that's rated 3 stars. So it's not super important. It's like medium importance. And this was this painful kind of like complicated study where we are solving the equation of motion by using coordinate partitioning. So memorize it, but don't invest too much time for this particular topic because it's not considered as one of the important ones. so, so coordinate partitioning, you select your coordinates to be dependent and independent, and then you do the same selection to your Jacobian matrix, and then you're good to go. And then and there was this painful part when you need to look at this. This is now correctly made. Now the equation of motion, you need to do this coordinate partitioning from acceleration level too. By the way, this is these are the slides that I need to figure out if there is a mistake, and there seems to be one. No, it's okay. It's okay. This is a correct one because remember you were able to pinpoint the mistakes in my original slides, which I will correct, and I will post the announcement where the mistakes were. So that was a coordinate partitioning and embedded technique. The hydraulics is the main body of today's or the next midterm exam. So these are the kind of the items you need to know. Hydraulic modeling, properties of fluids, medium importance. Very often there is a question about the bulk models. Not necessarily the one that you need to compute something, but you need to be able to explain it. And you need to select the proper or the correct option out of the menu. So that's a usual way how it goes. And just take a look at these slides and you understand how is that you can calculate the effective bulk modulus. That's something that is important to understand. Effective bulk modulus is the one that is describing the flexibility of entire system, not just the flexibility of the fluid. That's what it is. And that's a bit lengthy story. Then the line fluid theory, that's something that definitely there will be a question related to that. This is the one that you are discretizing your hydraulic circuit within the volume where you are assuming the pressure to be equally distributed. And then you have this first order differential equation to solve it. That's it. So that's how it goes. And here's that differential equation you need. So now understand what these components are representing. We definitely are not expecting you to derive this equation, but understand that, okay, like the effective bulk modulus is this BA. The V is a volume size. Flow rate in, flow rate out. What is it they are standing for? And the change of the volume. And practice that you can make the signs correctly. Because it's easy to say, more difficult to do. Okay? So let's continue then. I think I skipped something. Then the flow types. This could be a question too. Remember that there are two different flow types, laminar flow and turbulent flow. Most common is a turbulent flow. What happened? Okay, so you were saying, okay, I got it. I understand. Okay, in a turbulent flow, the pressure difference and the flow rate are quadratically associated. And somebody asking, like, where is this quadratic relation? It's the fact that the pressure difference is under the square root. So that's where it's coming from. There's a second order relation. So not the linear relation, but the second order relation. In a laminar flow, the relation is a linear relation. Okay? That's about it. That's the most important thing to know. Not too complicated. Valve modeling, that there is always some of the components there is this possibility or need to solve where the moving component is located at. Once you know that, then you can estimate the flow rate through your component. So that's what it is. And the semi-empirical modeling approach, memorize Heikki Handrus because he was the guy behind of this. And and then the idea of this concept is that you get started from analytical equation, you do the mathematical manipulation in a way that the parameters needed can be obtained from manufacturer's catalog. That's it. Simple like that. Direction valve. Remember that there is this concept that you first need to solve the spool position, and that's the one that is solving it. This is a typical question, like what this equation is representing. Yeah, that's the spool position, where the spool is traveling. And then there could be a question, okay, what? Oh, hold on. Let's put it back there. There could be a question, okay, what about this tau? What is a tau? What that is representing? So it's like how fast valve can react to control signal, how fast it can move the spool to one position to another position. That's essentially what that stands for. So those are the kind of the questions, typical questions. Okay, and yeah, that's about it. Then hydraulic cylinder and the pump models. The pump, remember that is the one that is producing the flow rate. Once you're limiting the flow rate, that's when you're going to get the pressure. So, but the models are producing the flow rate. And the cylinder is the one that is converting the the hydraulic pressure to be mechanical forces. So that's about it. Deformable bodies, not highly rated. So it's only 2 stars. So these are the 2 methods. There was also this one was based that I explained to you, this absolute Noddack formulation, but I don't expect you to memorize it because it's like advanced material, more like doctoral levels courses. So if you decided to do a doctor degree, then you need to learn that too. But not now, not this course, not this exam. Later, perhaps. Okay, real-time simulation memorizes different product processes, this customer feedback. Use your imagination if there's a need to explain something like that. So, with that, I see that we kind of would have a couple more minutes to go, but that's about it. The next course that I'm teaching is a simulation laboratory course, and it gets started in January. Don't remember what day in January, but it's 3rd period. So if you want to learn more about how the simulation can be used in practical applications, how you can model deformable bodies, that's your course. And it's usually kind of small group of people. So it's a lot of sharing ideas. Well, I cannot say that, a lot of sharing ideas, but I'm telling my ideas to you and then you're listening. But that's my way, my understanding about the communication. So I'm enjoying that communication. I don't know if you do that. Okay, so the final thing left is a chin-up competition. So we're gonna do it. Not today. What was that? Okay, so here's what I did yesterday. Video about the chin-up. Okay, so it should be counted. Yeah, I'm sorry, my battery is gonna die, so we're gonna leave it here. Ah, ah, but it's gonna die soon. Okay, let's. Okay, 1, 2, 3. Oh my God. 5, 6, 7, 17, 18, 21, 20. What? And one more. That was a one more. 14. 14. Okay. And my battery was able to stand that. So you can, if you can do more, just send me an email and I will give you one extra point. And I trust you if you say so. Only I know proofs needed. I know that there is a one proof that I already received. So there is a one video that I think that the reps were 20 something. That was extra point. That was worth of extra point. So if you say that you can do it, I trust that you can do it. Okay, 5 minutes left. Not much. So we spent time pretty much all the way from beginning to end. So it was good to see you guys face to face. Yeah, that's okay. That's okay. He's still playing that video. Is he still playing it? Yeah, yeah, yeah. So once, once per year. This course too, like this course, the simulation is once a year, and this other course is laboratory course is a once a year. So I'm not teaching. I'm only responsible of two courses per year, academic year. So one in the fall, another one in the spring. So that's worth to consider. It's not mandatory course for you, but you can select that as a voluntary course. Okay, honestly, I'm not 100% sure about that because it could be mandatory to you too, depending what's. How did you guys selected your specialty? What was that? Yes, your specialization. How did you make a selection? Or so how you selected mechatronics? Was it selected like when you were entering the university, or you did the selection afterwards? One semester. Okay, okay. Let me. But you guys are first year student now, so you are not yet made your decision, or you made it already. You will have to do it. So you do it. You have to do it in like once you pass the first period, or what? Okay. Okay. I see. So what are the options? How many different specialties you can sell? I mean, eight. Okay, I know. Then I know what you guys are saying. So this is the kind of the new system because I think they initiated that this year because it used to be three only, and now it's eight. Yeah, yeah, yeah. Of course, it's going to be difficult. It's going to be difficult because out of there's a eight specialization, you can get the courses for a couple of them. Rest is just guessing. The one that Emil is organizing. Right. But okay, okay. But this is the first time that you saw packaging and you were have to make your selection prior to that. That's kind of weird. That's a little bit weird. So did you select the packaging technology? Uh-huh. Okay. Who is what is this digital? Is it the one? The digital is the one that I'm doing with Jussi Sopanen, right? Is it? Mm. Okay. Okay. And then the robotics is a Heikki Handros. Okay. Good. Good. And then there is production engineering, welding, laser. Okay. Yeah. Mm. Okay. All right. I got it. The one thing that I love to deliver your lecture, but we don't have a time for that, but we'll see, is a career counseling. For some reason that I really like that particular topic. I don't know why, but I want to explain you how it, because some of you wanted to find a position in Finnish industry. What are the tricks to make that happen? And if you want to find your way to academia, what's important in that case? And what are the things you should do? What are the things you should not do? But maybe I'm going to make a recordings and you can take a look at it from my YouTube channel. We'll see. We'll see about the career counseling because it is an important story. You have any career counseling courses other than Emil's kind of course? No. Okay. Okay. So I'm going to make a recording about the career counseling because for some reason it's not really. My professorship is not the career counseling. It's computational dynamics, but for some reason I feel that this is something that I can tell you quite a bit. Yeah, yeah, right, right. I got it. It's a little bit like that, but a little bit like unwritten rules about that too. Because there are some things that are my experience about, what are the important matters to take care of. Anyways, I will consider to make a video out of that. And if, okay, so this is exactly why I would like to do this career counseling because the situation is changing radically at the moment. Because let me tell you a story that is a bit longer than that. Now let me see how is my battery. So this is about to die. So 15%, so it's okay. So when I started in the university, and again, I know that you hate these stories, like how life was 100 years ago, but still, I'm shortly going to mention that when I started in a university here in a professor, that was a 2002. At that time, all the teams in university they were fully occupied by Finnish members. So all the professors were Finnish, of course. Postdocs were Finnish. All the doctoral students were Finnish. So, and the communication was just Finnish communication, nothing else. And that was it. And then things started to slowly change, and it was like that 15 years ago. And look at the teams at the moment in the university. It's hard to find a Finnish doctoral student in a team, so it's almost like non-existing. Postdocs are fully occupied, mainly fully occupied by other than Finnish citizens. And professors slowly too, but that's of course the last step, which takes the longest than others. But there's a huge change. Also, the huge change in the mindset too. And now I can see that the same is happening in the Finnish industry. Some of the companies are fighting back, like they did fight back in the university too. I remember when we initiated the teaching in English, many professors at the time they say, "I'm not going to do it. I'd rather kill myself." And the response was like, "Hmm, not a bad idea." And then, and then then we were like, okay, well, I can teach them in English. So, but there was a huge resistance against that. You don't see that anymore. Everyone is teaching English, and it's not a problem. And I see the same change is happening in industry because they need manpower, female power, manpower, female power. And this is it. This is the way to get them. Okay, so let me hear what are the comments from online participants. Something about this. This when you need to do the selection. So it's a December 12th. We have to do the selection by December 12th. So you made it too early, I think. Did you not? Okay. Okay. Okay, so the audience is saying thank you very much because they would like to change their mind. So, okay, so I'm gonna close this streaming and I'm gonna close today's lecture too. Okay, but still this career counseling, I feel that is important, super important.